New video, 3.6, lesson 2. Let's get to it. So number 49, we already did in class. This is mostly for Charles's benefit. H of W equals cosine of 4W divided by 1 minus sine of 4W. All right, we got to do quotient rule, and we got to do chain rule inside of quotient rule. So again, rewrites in black, derivatives in red. So the derivative is the bottom rewritten, and I'm going to encapsulate the whole thing in brackets, times the derivative of the top. So the top has an outer function of cosine. The derivative of cosine is negative sine, and you have to keep whatever angle it is. Now you multiply by the derivative of the inside, which is just 4. I'm going to put the 4 out front like this to avoid another rewrite. Okay, so there's negative 4 out front right there. Minus the bottom oh wait, I just did that. I'm sorry. Minus the top times the derivative of the bottom. So that'd be 0 minus the derivative of sine is cosine, but the minus was there, so the minus remains. Minus negative cosine of 4W. And again, we're multiplying by the derivative of that inside, so there's going to be times 4 out here. Let's just call this negative 4. All divided by the bottom squared. 1 minus sine of 4W times itself. So at this point, we can take our negative 4 sine 4W, distribute it to both parts in here to see what happens. So you get negative 4 sine of 4W plus 4 sine squared of 4W. That's kind of light. Let's go to the purple. So took care of this. Now, plus 4 cosine squared of 4W. All of that's divided by, still, 1 minus sine of 4W squared. Now, normally we'd say, okay, circle it, it's done. But we're noticing something here. Sine squared plus cosine squared is 1. It's a pidentity. And they both have a 4 out front. So what if I factored that 4 out? I think that's a significant enough simplification. That's a significant enough simplification that you should do that. Because sine squared plus cosine squared, this entire quantity right here can be replaced with 1. And I'm just going to do that right now. So this entire quantity, sine squared plus cosine squared, is the same as 1. And now we have 1 minus sine of 4W. I'm going to rewrite that. Which is significant because look at the bottom. 1 minus sine of 4W. There's 2 of them. So one of them up top is going to cancel with one of these on the bottom. And your final answer is going to be, let's just put it below, 4 divided by 1 minus sine of 4w. All right, so make sure you guys still understand how to manipulate trig in that way, because a lot of times it pays off. Let's look at number 55. All right, 55. I think it's good to turn the root into a fractional exponent and then rewrite the cosine as brackets. So I'm not taking the derivative yet. I'm just saying that this is the cosine of 3 minus 8 theta to the half power. This whole thing is being multiplied by itself. So I think the purpose of putting this in the textbook was to test students to see, are they going to try to say that 2 and the half should be combined? Because they shouldn't. The 2 is attached to the entire thing. This 1/2 is only attached to the angle itself. So what we do is we say, our outermost function is theta squared. So you bring the 2 down when you take its derivative. You rewrite that whole thing. Now it's to the 1 power. Then you take the derivative of cosine of 3 minus 8 theta to the half. So now we say you're just taking the derivative of cosine, which is negative sine, and you have to repeat this because that's what the angle of cosine is, so that's what the angle of your derivative is going to be. We're not done yet. Now we take the derivative of our innermost function, which is the square root of 3 minus 8 theta, also written as 3 minus 8 theta to the half. So we got to do chain rule on that one. Times, I'm going to have to put it below. Bring the half down, rewrite, take 1 away, and then take the derivative of the inside. Wow. There's a reason why I picked this example. Okay. Times negative 8. So there's a lot of stuff going on there with chain rule. Let's see if we can make some sense of it. So recognize multiplication, 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 multiplication. There's not going to be anything, I think, that's going to factor out to create the plus 2 parts. We've got a negative times a negative, which means the whole thing's going to be positive. You've got 2 times a half, which is just 1 times 8. So it's going to be a positive 8. And that takes care of this part, this part, this part, and this part. Then you've got your trig. It's going to be cosine. Well, I don't know. It doesn't matter which one you put first. I'll just keep it as cosine first. And sine. And then, so that's gone, that's gone. Then you say, how about we just divide by 3 minus 8 theta to the half. And that's it. And don't try to cancel out one of these with one of those, because this is the angle connected to cosine. This is the angle connected to sine. This isn't the angle for anybody. Don't cancel it out. All right. Let's check that answer. Yeah, the only thing they did differently was they converted those halves back to square root. Let's check out 61. Actually, you know what? I don't think we need to check out 61. Let 61 be. We're going to move on to instead, I need to focus here, 65. 65. All right, this is a two-part thing. We're given this function. The point in question is 132. They want, for part A, they want a tangent line equation, which we've seen that before. They want a normal line equation. We've also seen that before. And then in part B, we want to find the place where the tangent line is horizontal. I'll just put it over here. B, horizontal tangent line. So, the slope of the tangent line is the derivative at the point specified. So m tan, the slope of that tangent line, is y prime, which is bring the 5 down, rewrite, take 1 away, multiply by the derivative of the inside, which is 1, plus, 1 over x is x to the negative 1 power. The derivative of x to the negative 1 is going to be minus 1 to x to the negative 2. I'm just going to call it 1 over x squared. So the derivative of 1 over x, it's kind of like saying you've got x to the negative 1 is now negative 1x to the negative 2, which I just rewrote as negative 1 over x squared. Okay? And we're plugging in the 1 for the x, because that's the point at which we're trying to find the tangent line's equation. So plug in 1 here. Slope equals 5 times 1 plus 1 over 1 to the 4th power times 1 minus 1 over 1 squared. So this is 5 times 1 plus 1 is 2. 2 to the 4 is 16. 1 over 1 squared is 1. 1 minus 1 is 0. All right, so... Wow. Okay. So it's one of those lines. So you choose the x equals 1, the y equals 32, m is 0. 32 equals 0 times 1 plus b. This is the y equals mx plus b I've been talking about. So 32 equals b. Y equals 0x plus 32 or just 32? All right, I want to make sure that I got this right because that looks kind of tricky. And I've made mistakes in the past. No, we're good. So that's the equation of the tangent line. The normal line, if you recall, is perpendicular to the tangent line. Y equals 32 is a horizontal line. What kind of lines are perpendicular to horizontal lines? Vertical lines. So vertical lines are, I'll just use the symbol for perpendicularity, are perpendicular to horizontal ones, which are written as x equals a number. So it's perpendicular to the y equals 32, and you write a horizontal line as x equals. What point does it have to go through? That one. The x coordinate is 1, so it's x equals 1. So this one is normal to y equals 32. Let's double check ourselves. That is correct. Now, a horizontal tangent line. Wait, we got the horizontal tangent line. That's a horizontal tangent line. Woohoo! Nice. All right. Now, do I want to split this up? This is a 15-minute 30 video so far. I had planned to do number 73 and 83 also. Is this going to take too long? You know what? I'm going to go for it. It's just going to be a long video. Brace yourselves. Pause it, get a cup of coffee, have a snack. We're bulldozing through this one. 73. Ugh. Maybe I should. Find the first and second derivatives of f of x equals sine cubed x. All right, so the first derivative, again, we're just using chain rule, nothing new here. It's sine of x to the third, so the first derivative is going to be bring the 3 down, rewrite the middle, take a power away from it, then take the derivative of the inside, which is going to be the derivative of sine is cosine. All right? Simple enough. So the first derivative is 3 sine squared x times cosine of x. Now let's double check ourselves before we go off trying to do the second derivative. The first derivative, we're good. Now the second derivative. Oh, this isn't too bad. You just got to use product rule now. Or we could use a pidenity to split it up, and then there won't be any product rule. Maybe we'll investigate that. So first is 3 sine squared x. Ah, shoot. Let's keep it consistent. Rewrites in black, derivatives in red. First times the derivative of the second, which is negative sine of x. No chain rule needed here because it's just cosine. Plus the second, which is the cosine of x, times the derivative of the first. This is going to be, so the derivative of 3 sine squared of x is 3 times the sine of x squared. Okay, the 3 shouldn't be included inside the sine. Bring the 2 down, you get a 6. Rewrite sine of x, take it to the 1 power, and then multiply by the derivative of the inside. The derivative of sine is cosine. So the final answer for the second derivative should be negative 3 sine cubed of x plus 6 sine of x times cosine squared of x. Now this was my initial thought. My initial thought on the first derivative, so this is sort of like an alternate route that you could explore if you wanted to, was what if we replaced sine squared of x with 1 minus cosine squared? It's pidenity. And I'm just curious if that actually makes things easier on us. So that'd be 3 times 1 minus cosine squared x times cosine of x. I'm just replacing sine squared with 1 minus cosine. That'd be 3 cosine of x times 1. 3 cosine of x times negative cosine squared. That just makes it cosine cubed. I mean, I don't know. What do you guys think? You take the second derivative. The derivative of cosine is negative sine, so it's going to be negative 3 sine. And then here, we would bring the 3 down to get negative 9. Cosine loses a power and then gets multiplied by its derivative. So the derivative of cosine is negative sine. So that leaves us with negative 3 sine of x plus 9 sine of x cosine squared of x. Which is interesting. It's a totally different derivative than the first one, but they're both equally correct. It's sort of like if I plug a number in for x in this expression, it's going to yield the exact same values as if I plugged it into the original. And I'm already thinking to myself like, hey, if we did some manipulation using pidentities, then that would easily make itself known. All right. I have to do one more example. 83. So once we get that, I'm hitting the stop button and you guys can rest. I guess you can always hit the pause. What am I saying? Okay. So 83. Last one I'm doing on this video, for sure. All right, ooh, they've got a lot of ifs going on here. I'm going to have to write some stuff up on the board. So here are the givens. F of t is given as a composite function, which is no big deal for us. We've been talking about chain rule in those terms. They're telling us f of 4 is equal to 3. G of 4 is equal, you know what? I kind of like looking at this vertically. That's also 3. 4. They want us to figure out what h prime of 4 is. Interesting. Okay, let's find the derivative. Whoop. The derivative of t is the derivative of the outside with the inside following times the derivative of the inside. We're concerned with at t equals 4, so I'm going to plug in 4 here, 4 there, and 4 here. Then I'm going to continue doing straight replacements. F prime of 4 is 2. H of 4 is 4. So it's G prime still of 4. And then H prime of 4, that's the thing we're trying to solve for. Then I can do another replacement of G prime of 4. That's negative 5. Get this by itself, you just got to divide by negative 5. Huh, that wasn't so bad. H prime of 4, it's negative 2/5. Double check our answer. Correct. All right, so does that change anything at all for me? No, I don't think so. All right, we're good. Hey, thanks for sticking around. That was a good effort by you guys, just enduring that video. Thank you for watching, and see ya.